Can you raise your hand if you have heard about the embedded template library before? That's fine. And who of you have used it in projects already? And who of you are not from BMW? Okay, that's fair. Thank you. So to have a short introduction, it is for everyone else, it is an embedded version of the standard template library that is well known from using C++. It's part of the standard, but the ETL is not part of the standard, and therefore there are a few differences intentionally, otherwise it wouldn't be necessary. So it was founded 12 years ago by John Welbeloff. So I'm just presenting the work of others here, so shamelessly doing that. But I'm using it and I'm also contributing to it. So that's why I try to show it to more people. Maybe after the talk we have even more people being involved if you're interested. There's a GitHub page for that, and as you can see, there have been more than 300 releases, even though small fixes also, but 300 different versions of the ETL over the last 12 years. Yes, and to get more into the details, some properties of ETL, as I said, John Welbeloff did that in the beginning by himself, but found many colleagues, also from us, from automotive, from avionics, from robotics. Many people are involved, and therefore many features. Hello, Volker. Many features were added, including several C++ versions up to 23, with some of the later versions just being added, but it's quite complete already. What did I write here? Some features of C++ are not really fit for embedded projects, so we are in the context of real-time embedded projects, and that's why we need to do some things differently. Most prominently, dynamic memory allocation, which is replaced by static memory allocation, like you decide on build time, at compile time, what you need, and therefore you can set up everything and be sure that you don't get the obvious problems like memory overflow or allocation issues, and even real-time problems that are fixed by laying out everything at build time, and then it's well possible to even get you into the domain of safety, which is an issue, of course, in automotive and avionics and so on. So, did I mention everything I wanted? I think so. Yeah, there are especially a few design patterns, let's say, in embedded projects that you need to take care for. So obviously size matters. So you have the decision how to lay out or how to design your objects, your code, both in terms of code and data. That's always an issue, and also specific to ETL is that some features are therefore provided a bit differently, but if possible, close to the STL, the STD library. So I brought you a few examples to get you an idea and a feeling what is similar or what is the same in ETL, like in STD, and what is different. For example, the first one is the vector that you can use as a vector, as known from the STL, but you always need to specify which maximum size you intend to use. And that is put here. So looks similar. Usage as from the STD version. Anyway, you won't get into trouble when you resize or add things to the vector if it overflows. We could get into the details here, but it's a lightning talk, so that's why I need to limit to a few examples, and you can ask only a few questions afterwards. You also have a different axis pattern here, the I vector, which removes the necessity for specifying always the maximum size, because you can imagine a vector of 10 elements is a different type than a vector of 11 elements. Therefore, you have the I vector, and then you can just use it, even though the object needs to be defined beforehand, of course. So that was the first example. The second example is the pool. So sometimes you still need dynamic memory usage patterns where you allocate stuff, for example, for communication protocols where you don't know beforehand which content comes and how much and how often. So you can define a pool of n elements of a data type. In this example 3, and you can allocate from it and give it back and use it with the respective type. And this is a way to emulate what you know from just allocating into a vector, for example. There is no malloc involved, and it's always limited to the maximum size that is given here. And you see a pattern emerges, so you always get maximum sizes for everything. And that's the second example. And the third example is close to the stuff that is currently in the works. So for modern C++ or the new versions since C++20, you have the urge in C++ to get rid of loops to prevent overflows and unexpected and undefined behavior. Therefore, in case of bugs, and that is being done in using ranges, of which I gave an example here that is actually existing code, but it's still in the development branch currently. But it actually works like this, and this is a pattern that is a one-to-one example, as you can use it in the STD version, except for the vector, of course. So you have a different vector definition, but the rest is the same as you know it from the STD. And yeah, that's basically it from the examples. Yes, now I come close to the end of the talk, of the lightning talk. Currently, safety is a topic we are working on to get basically more of the ETL to get safety qualified, because it is not in general currently. And some API from the standard is not available yet, even though only a small part. For example, the ranges is currently in the works, but I'm positive I can provide it soon. So, final words: get involved, have a look at it, try it out, and if there are questions, just ask. We have a few minutes for that, if you like. Anyone? Yes. 1, 2.
Thank you for the talk. You mentioned security. Is ETL MISRA compliant?
Not strictly. It's currently not enforced, but we are working on that, as you can imagine. That is part of the safety qualification, yes. Further questions? If not, one. Yeah.
Maybe it's a question that's obvious to anyone who's used the library, but I was wondering why there is a need for a vector with a specific size when there's an array that has a given size already.
You're right. You can back insert into a vector and use the obvious patterns, except for overloading it.
Okay. Thank you.
By the way, that's a good example, because you by using it for you, obviously it's clear, but by using it you get the fact that you're not working with you're working with a Turing complete language, but it's not a Turing machine that you are working with. It's especially a finished state machine that you're working with, and then you realize that. So think about it. Andreas?
And just to add to that, and to emphasize that this is not just important for embedded. In C++26, we will probably get a facility just like that with the name of in-place vector, which will work pretty much like this. So there are uses where you want that.
Yeah, great, thank you. I think we have time for one more question.
Thank you. The question was asked why a vector with a fixed size. Could I also ask what is the added benefit of having a pool on top of a vector of fixed sized?
You can allocate stuff and deallocate in an arbitrary manner. In a vector, you can't do that. Just not efficiently. It's different usage patterns and different implementations and different feature sets. So array is really fixed. It has always the same size, and it's always possible to use all the elements. In a vector that is fixed size, maximum size, it can still be empty, and it is empty from the beginning. So you specify a maximum size, but you still need to size or resize it or back insert to get it to some contents. Otherwise, it is either empty or smaller, actually. And we are now actually enforcing, that was not done from the beginning, but we are enforcing that you don't access elements, even though they are reserved for this maximum size. But if you haven't increased the size of the vector until before using it, then that is an error. And for the pool, it's similar to the vector, but as I said, you can allocate from a pool and give elements back, but in an arbitrary manner, similar to allocating memory via malloc. Does that make sense?
Yep. Thank you.
Okay. Do we have time for one more question, which is raised there? One more.
ETL use the exceptions. Yeah, so as you know, the exception use the dynamic memory allocations.
Sorry, I haven't get the question acoustically.
ETL use the exceptions, so through the exceptions internally, because the exception use the dynamic memory allocation. So when I see the introduction, actually, no dynamic allocation is
Yes.
Yeah, so
Yes. Dynamic memory allocation is that means everything you do with
Yeah.
on C level with malloc, on C++ level with vectors increasing and so on. But I'm not sure I got your question right.
yeah, sorry. As you know, the exception use the dynamic memory allocation internally. So if the ETL use the exceptions through the exception, actually the ETL will use the dynamic memory allocation.
So sorry, maybe someone can translate. I misunderstood the friction or sorry.
Exception.
Exception, yes. And do you wonder if you get an exception then? Yes, error handling in ETL, sorry. You have several options to configure at build time, and you have several options either to ignore such stuff, then you get undefined behavior, if you allow that, but maybe you can prevent it otherwise. You can get exceptions, you can allow exceptions, or as you know from C++, but in embedded context, you can compile without exception support, which is typically done, but you can do asserts instead. So it's mapped to an assert function that you can implement then, and that's several options. There are more corner case options, but you can choose from a handful of things that happen when errors occur. So that's different error handling patterns, error handling options you can choose from. Does that answer the question? Okay, then thank you very much, and I can hand over to Artemi.